Okay, class, I am not going to be here today, so I listed the instructions on Google Classroom. You are going to listen to this video first, fill it in your books, and then what remaining time we have left, you guys can work on the homework that will be due on Tuesday since we are not here Monday, okay? So, starting off, this is going to be lesson 26.2, which is talking about square root and quadratic functions. Prior to this, we talked about square root and we talked about quadratic functions. We also talked about how to find the inverses. So now what we're going to be able to do is tell whether or not we have to put a restriction on it and then find the relation between both functions. Okay? So this is on page 406 in your book. So if you want to flip to it now, feel free to do that. Also, if at any point you want to pause or rewind this video, feel free to do that as well. Okay? Okay, so let's talk about just inverse relations, okay? Here's what the definition is. It says all functions do in fact have an inverse relation, but that relation may not always be a function. In order for something to be a function, remember, on the graph, it has to pass the vertical line test, okay? If it does not pass that test, then it is not a function, meaning it only touches once, okay? So if you're looking at the graph on the right, okay, this parabola is a function because it passes that vertical line test, okay? So what we're going to start off with is it says graph the inverse of g, okay? Easiest way to do this is find a couple points on that picture, okay? So like this point right here, 4, 0, then maybe choose 2 points on either side, here and there. Okay, this point would be 2, 8, and this point over here is -2, 8, okay? To find the inverse, what we want to do is we want to basically switch x and y terms, okay? So in other words, that first point, -2, 8, would become 8, -2. The second point, 0, 0, would just stay because you would switch. It stays the same. Oh, I'm sorry. This was my mistake. This point right here should become 0, 4. So switched, it would become 4, 0. Okay, and then for that last point, it becomes 8, 2. Okay, so then we're just going to graph those points on our graph. Starting off with 8, -2, it'd be down here. Okay, 4, 0 would be here, and then 8, 2 would be here. So it would be this lying on its side. Okay. Okay, so that's the graph. We're going to call that G because that's what the inverse is. Okay, so in part B it says, is the inverse of g of x a function? Well, in this case, we want to do the same thing. We want to see if it passes that vertical line test. In this case, it doesn't, and it touches twice. So the answer is no, because it fails the VLT, or vertical line test. Okay, that's why. Okay, so we want to figure out a way in which we can get that to be a function of that. Okay, so just some questions about the graph. It says, what characteristics of the graph of a function can you use to determine whether or not the inverse relation is a function? Well, the biggest thing is if you have, okay, on your original function, okay, if you have a repeated, and this is going to be specific, okay, if you have a repeated y value, okay, you can have that be a function, okay, but on the inverse, it's going to switch to be a repeated x value, okay, which in the case of whether or not it's a function, you cannot have a repeated value, or a repeated x value, okay. So we're just kind of noticing patterns with that, okay? Part D is going to be, it says, given the domain and range of the inverse relation in part A. I'm just going to write the two different ways, which are inequality and interval notation. Don't worry too much about set notation, okay? So starting off with the, let's start off with this function right here, okay? You're looking at, for the domain, okay, where do x values exist and where do they go to? Okay, so this is the domain of, I should say, f of x, the original function. Okay, so starting with x values start, okay, these arrows keep going on and on forever and ever. Okay, so in other words, it would go from -infinity to +infinity, or in the interval notation, it would be open parentheses, infinity to infinity. Okay. For the range, you're looking at where y values start and end. Okay. So again, y values are lowest here, so that would be at 4, okay, including 4, and then it never stops, so it goes towards infinity. So in interval notation, it would be 4 to infinity. Okay, that's for f of x. We're going to do the same thing for g of x. Okay, so starting with domain. Okay, domain for g of x is where do x's start? Well, if you notice here, x's start at that spot there, which is 4, and then they never stop, so it would be to infinity. Okay, and then for the range, okay, it's your y values. If you notice on your graph, it's from here to there. Those y values keep extending on forever. So it's from negative infinity to positive infinity, okay? Biggest thing is I want you guys to notice here how the range here becomes the domain of the inverse. And then similarly, the domain of the original function becomes the range. That's not a surprise because we want to think about inverses or opposites, so then essentially their domain and ranges switch, okay? Okay, so because of that, what we can do is we can then find the inverse of a quadratic function, okay? So let me just show you how to do this, like with this example, and then we'll do one on our own, okay? All right, so what we're going to start off with is you're always going to start with replacing y with g of x, okay? Your second step is to interchange both x and y. So x becomes here, and then y becomes here, okay? And then we're solving for y. So the first step would be to subtract 4 to both sides. So you get x minus 4 equals y squared. Now, when you take the square root, okay, what you have to add is this. You have to add a plus or minus sign, okay? And what that means is it has both the positive and the negative part of that parabola, okay? So in other words, you would have plus or minus the 4 minus x minus 4 raised to the 1/2 equals y, okay? And so that would be your solution, okay? So that's just how we find the inverse. We're going to try a couple on our own, yeah? So here's what we're going to do, is it says find the inverse of the function negative x raised to the 1/2. State whether or not this is, the inverse is a function, okay? So what we're going to start off with is, okay, for A, I'm going to replace f of x with y. So I would get y is equal to negative x to the 1/2, okay? This is also the same thing as this, okay? We also want to think about y is equal to negative square root of x, okay? That's what it means. So then what I'm going to do is I'm going to replace x, switch x and y, so it becomes x equals negative square root of y, okay? And then solve for y. So my first step is, I have that negative 1 out front. I'm going to divide both by negative 1. So you get negative x equals square root of y, okay? And then from there, what I would do is to undo the squared, I would square both sides, okay? And so you would get y equals, when you square a negative x, you're actually going to give it to be positive x squared, okay? And then just finally replacing it with that inverse sign, it would be f inverse of x equals x squared, okay? That would be your inverse. But then it's asking you whether or not the inverse is a function. Well, the way you want to think of it is this is just a parabola that starts at 0, 0 and goes up. It passes that vertical line test, which means that, yes, it is a function, okay, because it passes the vertical line test. Okay, so you can just graph that either on your paper or on your calculator to determine if it's a function, okay? Okay. So the next one's going to be, it says find the inverse of the function g of x. So you remember, you're going to replace g of x with y. Okay, I'm going to move this up here. Okay. Equals, you're going to do x minus 5 squared. Okay. And so when I do that, what I'm going to do is first, I'm going to switch x and y. So you get x is equal to y minus 5 squared. Okay. what I'm going to do is this, okay, is I'm going to take the square root of this side, but I have to add that plus or minus sign every single time I do that. So plus or minus x, square root of x, equals, on the left it's just going to be y minus 5, okay? And then finally, to solve for y, you would just add 5, so it'd be 5 plus or minus, okay, the square root of x equals y. And so what I would do is I would just simply do this, g inverse of x equals 5 plus or minus x, okay? So here's what we want to think about, is we want to think about what that looks like. Well, this is just simply a square root function that is moving over to the left 5. So it's like this, okay? It's on its side. Okay, so what we're going to think about is this. Does it pass that vertical line test? In this case, it's no, because it does not pass. So it's not a function. Okay. Okay. So what we're going to do now is we're going to think a little bit. Okay. It says in try these A part A, why is it necessary to include a restriction on the domain in the definition of G to the negative 1, which is the inverse, okay? Why it's necessary to include a restriction is because otherwise it's not a function. Okay. Okay. And this is what kind of that second part says. So we're going to figure out a way to place a restriction on the inverse. Okay. So let's do this, okay, is we are going to look at the graph that we've done before, okay, and we're going to look at the inverse to see how we can basically place a restriction, okay. So starting off with this was the same as before, so if I flipped it, it would become 4, 0, 8, 2, and 8, negative 2, which is this parabola looking, okay. Now, you need to think for a second. You need to think, like, what will make it past that vertical line test, okay? Here's what's going to happen, okay, is let's just say, for case of restrictions, that this bottom part was not included, okay? What would end up happening is that would actually be a function then because it would pass the vertical line test. So, what did I just do? Well, basically what I did is I canceled out... Okay, I'm just writing some observations. Any negative y values. Okay, which means if I'm canceling out any negative y values, where it would have to exist would be when x or y is greater than or equal to 0. Okay. So remember what I said, when you have y is greater than or equal to 0, talking about the inverse, okay, you want to think like that's going to be the domain of the original. So how I would figure out the original is I would just simply put a restriction on the fact that x has to be greater than or equal to 0, and that would be your restriction. Okay. All right, so that's one way. Another possible way is this. Imagine if I canceled out, I'm looking at my inverse, I canceled out this part, okay, which is when y is positive. That means it would have to be when y is less than 0 for the inverse, okay. It's the opposite for the original, so it's when x is less than or equal to 0. This is your restriction, okay. And we'll talk more about this later on, okay. Okay, so here's what we're going to talk about, okay, is we're going to, you can try out these problems. I'm going to go through these problems probably on Tuesday, so we'll just bookmark those for now, okay, but what we're going to talk about is, let's just say for, like, this sake, what were we trying to figure out, okay, we are trying to figure out a restriction to put so that it would, the inverse would be a relation. In my opinion, that's a little harder, okay? So here's what we're going to talk about, okay? We're going to talk about one-to-one, okay? This is what makes it easier so you don't have to assume there's a restriction, okay? So it says in one-to-one, it says if f of x is a one-to-one function, then it passes both the vertical and the horizontal line test. So let me show you what that means, okay? Is if we are looking at this parabola, okay, from that example above, okay, it passes the vertical line test because it passes through. So vertical line test, good, okay? Horizontal line test, okay, deals with this. If I'm looking at drawing a horizontal line, okay, if it touches in two or more places, which in this case it does, that does not pass, okay? So in other words, in order for it to be one-to-one, it has to pass both the vertical and horizontal line test. It would be no, because it does not pass specifically the horizontal line test. That's how we know it's one-to-one, okay? Okay, so then it says make a conjecture about the function whose inverse relation is a function, okay? Inverse relation, it just means basically switching those two. So in order for an inverse relation to be a function, it has to pass both the vertical line test and the horizontal line test, okay? Otherwise, it is not a function. Okay. So that's what will be happening. Okay. Okay, so we're just gonna basically practice this using both vertical and horizontal line tests, okay? All right, so starting off with this, it says a linear function. A linear function just looks like this, okay? So I'm just drawing it out. It's just basically a line, okay? So you're looking for, does it pass the horizontal line test and the vertical line test? In this case, it does. So here it passes, and then also here. Okay, so it says determine whether each type of function will always, sometimes, or never have an inverse that is a function. Okay, assuming the domain has not been restricted. Explain your reason. For a linear function, it's always going to be because it passes both tests. Okay, all right, a quadratic function. That's going to be like your parabola. Okay, so in this case, what's going to happen is it's going to pass the vertical line test, which is good, but it does not pass that horizontal line test. So this one would be never. Okay. And then the square root function is something that looks like that. It passes the vertical line test, okay, and it passes the horizontal line test, but here's what we need to think about. Imagine that existed right there. So this would be sometimes, okay? So you just have to think for, does it pass vertical and horizontal? Okay, cool. All right, so here's what we're gonna do is I'll post these notes now, okay? This is your homework. So you're gonna do numbers 14 through 18. Try your best, okay? I'm not asking for perfection, but I am asking for you to at least attempt these problems, okay? But that's basically it. If you guys wanna sign off, you can.